The biggest limiter on advanced AI is no longer raw intelligence. It is whether you can delegate real authority and still keep accountability. By 2026, frontier systems already blend language modeling, retrieval, multimodal perception, tool use, and workflow orchestration. They can draft, search, summarize, and call software tools, often impressively. Yet reliability stays strongest in bounded tasks and weakest in open-ended institutional settings. That gap matters, because institutions are exactly where the consequences compound. So the core problem shifts. The question is not, can the model answer? The question is, can the system act, under supervision, with a traceable chain of responsibility? Verification, responsibility mapping, auditability, escalation, and contestability become the real deployment constraints. In other words, delegated reasoning under accountability. Once you notice that, a lot of the last decade of AI debate looks misaimed. People argue about which model is smartest. Meanwhile, organizations quietly discover that their hardest problem is governance plumbing. Who approved what based on which evidence, using which tool, under which permission, with which logs, and with which fallback when something feels off. One of the most useful lenses here comes from cognitive science, not because machines are becoming human, but because cognitive constructs give you a vocabulary for control and failure. Attention, executive control, and explanatory vocabulary help describe what a system is prioritizing, what it is suppressing, and what it is allowed to do next. Those words become design primitives for machine cognition stacks. Attention is not just a metaphor. It is the engineering question of what enters working memory, what gets queued, and what gets ignored. Executive control becomes the machinery that switches tasks, enforces policy, detects conflicts, and triggers escalation. When these functions are weak, you see familiar agent failures. The system chases irrelevant threads, misreads the goal, or continues confidently past an uncertainty threshold. A second high-impact shift is how evaluation is changing. Static benchmarks are fading as the dominant signal. They are being replaced by observable agent conduct inside interaction platforms. That means you care about refusal behavior, escalation behavior, tool use discipline, and oversight response. You also care about behavior drift over time, because institutions run on weeks and quarters, not single prompts. This is a strategic change for leaders. Benchmarks tell you what the model can do in a lab. Behavioral evaluation tells you how the agent behaves when embedded in your workflows, especially when it meets ambiguity, policy conflicts, missing data, or adversarial instructions. For high-authority settings, got the right answer once is not the bar. Behaved predictably, under uncertainty, policy conflicts, and missing data, safely and contestably for a long time is the bar. Now add simulation. Simulator-based training is already real in high-stakes operator environments. Power plant operator training, for example, uses simulators to expose trainees to rare events under controlled conditions. That is a clue for machine cognition, because you will not get enough real-world failures to learn safely. You will need synthetic environments to practice decision behavior. But simulation introduces its own trap. Transfer from simulator behavior to open-world institutional cognition remains a bottleneck. A simulator can never capture every weird edge case, every novel adversary, or every political constraint. So simulation has to be paired with validation. You compare simulator performance against real incidents, near misses, operator overrides, and deviations. If you cannot do that, you are training confidence, not competence. Another insight is easy to miss because it sounds philosophical, but it is operational. Human and machine cognition will be hybrid by default, unless governance forbids machine participation. People will ask for drafts, options, risk summaries, and proposed actions. Machines will generate, humans will interpret, and systems will execute. The hard question is where epistemic value resides in that chain. If an AI system produces a recommendation, who knows it is right? Is knowledge in the evidence, in the model's synthesis, in the human's judgment, or in the institution's approval procedure? The answer cannot be vibes. It has to be reconstructible. For any significant decision, you want to separate generated content, interpreted evidence, human judgment, automated execution, and accountable approval. Without that separation, you get accountability laundering. Responsibility diffuses across vendors, operators, and committees until no one owns the harm. Natural language supervision makes this even sharper. Research shows language can guide robotic awareness and action selection in constrained settings. Language is a powerful supervisory interface. It is also dangerously ambiguous. A sentence can sound like permission when it is only intent. So language should not be the authorization surface for high-stakes action. The safer pattern is authority separation. Instruction interpretation is one thing. Permission to act is another. Before execution, actions should pass through machine-verifiable policy constraints, scoped permissions, and tool safety checks. If a system cannot prove it is allowed, it should escalate, not guess. Zooming out to the long horizon, the decisive engineering band is the near term, from 2026 to 2050. That is when enterprise agents and bounded high-stakes decision support become normal. The decisive governance band comes later, from 2050 to 2100. When institutional cognition stacks and regulated delegation either mature or fragment under mistrust. Beyond that, long and deep futures depend on whether accountability compounds. If machine cognition becomes auditable, it becomes infrastructure. If it remains opaque, it stays a capability layer that institutions use cautiously, and only in limited scopes. It also helps to name the limits correctly. Some constraints are physical. Compute is finite. Energy is finite. Sensors are uncertain. Light speed delay becomes real when operations spread across long distances. Other limits are engineering, robustness, verification, memory, simulation fidelity, tool safety, and model drift. Then there are coordination limits, which often dominate: authority, liability, institutional capture, public trust, and cross-border accountability. In the near term, the ceiling is mostly engineering and coordination, not physics. That means progress is less about a magical new model. It is more about building control stacks that make delegation safe enough to scale. So what should leaders do with this? First, treat machine cognition as governed infrastructure before granting durable institutional authority. Model access is not the asset by itself. The asset is a control stack that can scope what the system may do and prove what it did. In practice, that means procurement defaults. No persistent delegated authority without logs, scope limits, escalation paths, and contestability. Every delegated action should map to a permission, an evidence trail, a decision rationale, a supervising role, and an escalation path. If you cannot produce that within one audit cycle, you do not have an institution-grade system, you have a demo. Second, invest in evaluation like it is safety engineering, not marketing. Measure refusal consistency, escalation latency, tool use exception rates, and audit log completeness. Track behavior drift, because long-running agents will change as tools, policies, and environments shift. Third, hire for the missing disciplines. You need mixed teams. Machine learning engineers, yes. Also cognitive scientists who understand attention and control. Safety evaluators who can design behavioral tests. Domain operators who know what rare failures look like. Governance specialists who can map responsibility and liability into executable scopes. Fourth, prioritize simulation and behavioral testing partnerships over generic branding partnerships. Vendor demos and benchmark slides do not tell you how an agent behaves at 3 a.m. in a messy incident queue. A validated simulator and an instrumented interaction testbed gets you closer to the truth. Finally, classify systems by authority level, not by model family. A small model with high permissions can be more dangerous than a frontier model used only for drafting. Create an authority register. Map each deployed system to permissions, data access, tools, oversight, and shutdown procedures. Then watch for authority creep, because it is the silent path from assistant to operator. By 2040, civilization-scale machine cognition remains speculative, and legitimacy is the hard part. The near-term choice is simpler and more urgent. Build the accountability rails now, or you will spend decades chasing capability you cannot safely use.